In this video, we're going to talk about kind of a simpler concept in organic chemistry, and the idea is that determine if a solution or a solute is going to be soluble in a solvent, right? So let's say we have sodium chloride as our solute, and let's say you mix sodium chloride in this structure. No, this is our solvent. The question is it soluble? Would these be soluble or insoluble, right? And tell me why. Well, in organic chemistry, remember that our electronegative atoms tend to be involved in stuff that are polar. So if something is usually polar, that means it's going to be soluble, usually in something that is polar itself. Now, if you look at this structure, and this structure is actually what we call toluene, it's an organic solvent, is we don't see any hydrogen bonding, no ionic forces, right? This is just purely hydrophobic. And so this structure is hydrophobic, toluene, whereas sodium chloride, we would say that is actually very polar. Why? Because it's ionic, right? This, like we said before, the structure toluene would be non-polar, as there's no ionic forces, there's no hydrogen bonding, it's just purely hydrophobic. And so in this case, it would be insoluble. How about this one, right? How about glucose and methanol, right? Now, methanol formula is CH3OH. Glucose is multiple R groups with various OHs in its structure. So I'm just going to say R1, R prime, R2, right? So this is kind of the structure of glucose, and here's methanol. So the question is, are these soluble or are they insoluble, right? And the idea is they should be soluble, right? Because here we're seeing hydrogen bonding. So we're seeing some sort of polarity. And here we also see hydrogen bonding, right? So both these structures are severely polar, and so in this case, these two would actually be soluble. How about if we looked at benzene, right? So here's the structure of benzene. So that is benzene. So how about benzene as the solute, and we put that in water as a solvent, right? The question here is, are they soluble So are they soluble? Are they insoluble? Right? Again, look at the forces. We know water structure is H2O. So we do have some sort of hydrogen bond in there. Alright, so we know this structure is polar. Benzene, on the other hand, we only see hydrogen and carbons. There's no ionic forces, there's no hydrogen bonding. In fact, there's no electronegative atom, and so you would expect benzene to not be soluble in water, and so these would be insoluble. How about these two. How about caffeine, stuff that we actually love to drink, and water? All right, water in this case will be your solvent, and caffeine will be your solute. Would these be soluble? Would these be solid or insoluble? Well, we know that water, H2O, is polar, right, because of the hydrogen bonding. And caffeine, on the other hand, it is in fact is polar. So caffeine, even though you do not know the structure, this is one of the reasons why we can actually make coffee, right? And so caffeine has various hydrogen bonding to a structure, and so we say these are in fact soluble. All right, so this is just a quick video to kind of decipher and to even progress and to kind of give you some insight into, if you want to do research in organic chemistry, etc., some of the stuff that you can mix and some of the stuff that you cannot mix.